Now we're going to do a minimum length problem. These are kind of fun. Suppose I have two tents, and they are standing side by side. One is 10 feet high, and one is 15 feet high, and they're 25 feet apart. So this total distance here is 25 feet. All right? And they're to be stayed by two ropes attached to a single stake running to the ground. Where should they be placed to use the least amount of rope? Now, from this point to this point, we're going to call Y. From this point to this point, we're going to call Z. So this is where they're being staked. And I have the distance X, and then the distance 25 minus X. Now, I know I have a length of rope, and the length of my rope is Y plus Z. That's way too many variables. Is there some way to relate Y and Z? And the answer is, yeah. Let's look at what Y is. By Pythagoras, Y squared is 10 squared plus X squared. So I'm going to solve this for Y. Y is the square root of X squared plus 100. Similarly, Z squared is 15 squared plus 25 minus X, and that is this, and this is squared. Now, I'm going to multiply this out and collect terms. I don't really have enough room here, but I'm going to do it anyway. Z squared is, 225 plus 625 minus 50x minus x squared, or excuse me, plus x squared. So Z squared, when I simplify this, is x squared minus 50x plus 850. So I'm going to come over here. I have x, I have y, and now I have z is the square root of x squared minus 50x plus 850. All right, so let's rewrite my R equation. R is y, which is the square root of x squared, plus 100, plus z, which is ugly, but it's x squared, minus 50x, plus 850. All right. Yeah, we're going to have to take the derivative of this, folks, but that's all right, you can do it. First of all, for the domain, I know that it simply needs to be positive. I know it needs to be positive. Let's just go on from there. Let's get through this derivative because this is going to be ugly. R prime is, take a deep breath, 1/2. Okay, so it's going to be, this is going to be the square root of x squared plus 100 on the denominator. The derivative of the inside is 2x plus 1/2. We're going to do the same thing here. Square root of x squared minus 50x plus 850. The derivative of the inside is 2x minus 50. All right. When is this 0? Well, let's see. It's 0 when I'm going to go and cross this 2's out there. I'm going to cross out a 2 here and replace this with a 25. Okay, so when I solve this, I've got x divided by the square root of x squared plus 100 equals, now I'm going to switch these two around because I'm going to add it to the negative side, 25 minus x divided by the square root of x squared minus 50x plus 850. Yuck. Okay, let's cross multiply. And square all at the same time. Okay, so I'm going to square the whole thing and cross multiply because I'm kind of running out of room here. So this is x squared times x squared minus 50x plus 850 equals x squared plus 100 times 25 minus x squared. I know it's kind of ugly, isn't it? All right, you ready to do this? I'm going to multiply this out up here because tell you what, I'm going to multiply it over here. That's all right. This is x squared plus 100. I'm just worried about running out of space. When I multiply this out, 25 squared is 625 minus 50x plus x squared. All right. Now I'm going to distribute. Ready? All right. Let's see if I can do this without making a mistake. X to the fourth minus 50x cubed plus 850x squared. Okay, I did that one pretty easily. Now let me see if I can do this one. All right. Oh, God, this is a mess. 625x squared minus 50x cubed plus x to the fourth plus 62500 minus 5000x plus 100x squared. Okay, God, let's see if anything cancels. X to the fourth here, x to the fourth here. Yay, that goes away. I'm going to change my pen because I love crossing things out in red and not just on your paper. Okay, those cancel. Let's look at the x cubed terms. Oh, they're awesome. They're going to cancel as well. Let me switch to green. So now let me collect my x squared terms. So this is x squared times 850 minus 625 minus 100. All right. Now let me do my next terms. I'm just going to add everything over here. So this is going to be plus 5,000 x minus 62500, and that's everything. Okay, this equals 0. So I need to rewrite this. This becomes 125 x squared, oh God, plus 5,000 x minus 62500. Let me factor this 125 out, and I'm left with 125 x squared plus 40x minus 50. Now when I factor this, oh, this one's going to be nice. 125 goes away. I've got x minus 10 and x plus 50. So I have two answers. One is when x is 10 and one is when x is negative 50. Now that's not an answer, so it's out of range. Or excuse me, it's out of the domain. All right, now let's look at when x is 10. Let's look at our endpoints. Let's look at what r is when x is 0. So suppose we're at x is 0 and then x is 25. So r of 0 is not very attractive. It's a square root of 100 plus a square root of 850. And that's about 39.15. Okay. Now let's do r of 10. Let me switch pen colors here. Is, okay, it's going to be the square root of 200 plus the square root of 10 squared is 100 minus 50 times 10 plus 850. When I put this in my calculator, I get this is about 35.35. And then let's look at when x, let's evaluate r when x is 25 at the other endpoint. Oh, what a mess. This is the square root of 25 squared plus 100 plus, carry square here, the square root of 25 squared minus 50 times 25. Can't do all these in my head here. Plus 850. All right, I'm going to cheat at my calculator. And this is about 41.925. All right. Now, what were we asking for? We want to use the least amount of row. Which one of these is the least? Well, lo and behold, r equals 10 is the least. So we want to place it at x equals 10 from the left. And there's our answer. It's a lot of algebra. Be careful with your cross multiplying. Give it a go. Oops. Wrong problem. Try that one. Give it a go. And when you're done with the problem, stop and finish your homework.